Hello, we are here for one more lesson of this SprutCAM training course. Today we are going to see some of the most important 3D milling toolpaths, and the lesson is called 3D milling. I will not lose much time on the parameters, as in some of the previous videos and in some of the future videos we are going to see some of these parameters. They are not very different from each other. We've seen some also. I'm most worried, and my goal it is to show you what each of the toolpaths we are going to see does, so that you can understand what can be obtained from each one of those. So starting with the roughing toolpaths, first one called face milling. I will not choose any parameters. I will calculate by default always. So running, and as you can see, the face milling basically cleans the initial face of the block that we can consider for machining. So can do this kind of behavior, but we can change a little this behavior. But the idea it is to clean the face. Then we have something called roughing waterline. Roughing waterline is the roughing toolpath by excellence, and it will clean up the block by levels. So 1, 2, 3 levels. We could increase more levels if we want, but this is the most important, I would say, toolpath to make a first roughing and to cut the initial material. Another way to do a roughing, it is a roughing plan. And the roughing plan, it's a little different because it does a little stranger milling toolpath with the intention to do a roughing, but it will create these roughings following the part, but by levels also, okay? I would personally recommend not this one, but the roughing waterline. It is not a question of being favorite or not, but I think it's much more interesting in terms of roughing. This one, pocketing, more suitable for pockets. Holes we've seen already, and these ones are special, so not important for today. In terms of finishing, we have a couple of toolpaths, 2D contouring and 3D contouring for curves. So this one will follow only on 2D plan. This will follow a 3D part. It's a good program also, but for this particular part I will not show you. Going to first one, I will jump this one. Finishing morph, I need to have some surfaces, but basically it's a finishing tool path. I will do first one, this scallop. And the scallop, as you can see, it's a very nice program because it will follow limits. In this particular case, it is following the limits of our part, and does that following always the same distance, the same scallop height to all the parts. So it is a very good looking program, and it will give very nice finishing results. Then we have 3D helical. It's not the same, so it will basically it will finish a part by 3D helical movement going down by levels. I'm not a big fan of this one. I think it is much more interesting, the one I will show you after. Being a helical movement, so you can see that we have some areas where the passes are not so constant, and this is why I don't like it very much, okay? Finishing, we have this one, rotary, not interesting. The finishing waterline, that basically it's similar to the helical, but this time much more clean program, and we can control the entry points and how enters the part and leaves the part, so can do a very clean and very nice looking program, especially for vertical or almost vertical walls. Now there are a couple of milling toolpaths which combine two of those. But first, we have this flatland. Flatland basically finishes flat areas, as you can see. So if it is 0 degrees in terms of draft, then it can be clean as the first face milling, if you remember. Then we have something called finishing plan, which is, I would say, the most known type of program for finishing. I usually call it as a copy because in old days we had copy machines that basically copy the model, a physical model, and replicate that movement to mill a part. So basically they do this kind of finishing following all the part. The problem of these toolpaths it is that in certain areas, depending on the orientation of the part, the quality of the finishing is not good. As you can see in this area here, you see that the distance is more or less similar in this area, and in this area here, because it follows the direction, it's a little bigger, which in terms of finishing does not give the best of the results. And to overcome that problem, we have this kind of toolpaths. The first one called Finishing Optimized Plan, which in the end combines two programs in only one. So following a direction, as you can see, we have this copy toolpath in one direction, and we have on a perpendicular direction the same copy idea, and they connect. So in the end, we will get a very nice program. Okay. Other ideas for this, we have the finishing complex, and the finishing complex, it's the same goal, but this time combines a copy, as you can see in this area on the top. Okay, we have copies, and when we go to more vertical walls, we go to finishing by levels, by waterline. Okay, which is a very nice complement also to finish a part. Going down, we have the finishing combine, which basically will do a cleaning in some areas and of the flats, and will do also a waterline. So it's another option. And in terms of finishing of what I'd like to show you today, these are the most important. We have also engraving. In this particular part, we don't have nothing to engrave, but basically, if you have some contours, we can engrave those contours, letters, whatever, following the shape of a part. Okay. These ones, jet cutting and 5D contouring, are for other purposes. More, we have another group called rest machining, and rest machining basically it's very useful when we are either going from a big tool in terms of roughing, or doing the finishing passes from a bigger tool to a smaller tool. And we have two possibilities: corners cleanup, which I will also calculate. And the idea in this corners cleanup, it is we have some parameters defined, and the program looks for areas where this smaller tool that we are passing now will mill only due to the excess material that the big tool left. If we go inside parameters, so strategy, we can see that there is a parameter here called previous tool diameter. I'm not sure what was the tool that it is chosen now. Okay, 6 mil diameter, and it consider that previously he had a 12 millimeter diameter, so it is this difference that the program will find, and it is milling so that this excess material left by the previous one, it is removed. With the same purpose, because it's also rest machining tool path, we have something called a pencil, and basically it will do the same, but instead of doing multiple passes, it will create only one pass in these areas. So it is a kind of a final cleanup of these areas, because even if we do the previous multi passes, we get some scallops. So with this kind of tool path, we will clean and smooth all of these areas. So these are the things we can obtain from the 3D milling. I hope these brief examples are clear and give you some more ideas so that you can use as an additional set of tools for your work. Any help, any clarification that you may need about these topics or other topics, let us know. We are here to give you all the necessary support.